Power rule with negative exponents. We've already talked about the power rule before on the previous page. We said if we had x to the m raised to the n power that our rule was to do m times n, right? When we raise to a power. So we're going to start by basically doing that same rule. I have v to the negative fourth raised to the third power. If I multiply my exponents, I get v to the negative 12th power. However, we also learned on the previous page that we don't like to have negative exponents, right? So if we have a negative exponent, we want to rewrite it without the negative exponent. And how did we do that?
Oh, I forgot already.
Yesterday was a long time ago. To get rid of the negative exponent, we have to do the reciprocal.
Okay, yeah.
So we're going to write our answer as 1 over v to the 12th power. Now number 2 then, if I follow my rule, I have u to the negative 7th raised to the negative 6th power, I would get
42.
u to the 42nd. This one already has a positive exponent, so we don't have to do anything with it. That's just going to be my answer, u to the 42nd power. So on number 3, if I'm going to simplify that one, what am I going to do?
Negative 30.
I'm going to have y to the negative 30, and if I get y to the negative 30, I still need to simplify that. So I'm going to write that as
1 over y to the 30.
1 over y to the 30th, exactly. There's my answer. Number 4, we are doing scientific notation. Now, scientific notation is usually used in science to write really, really big numbers or really, really small numbers. Like if I was going to do the distance from the Earth to the moon, I wouldn't want to have to put 50 zeros on the end of my number. So we use scientific notation. This number right here is written in scientific notation. This part in the front has to be a value between 1 and 10, or negative 1 and negative 10 if we're doing negatives. Then it's multiplied by a power of 10. If I'm multiplying by 10 to the 5th, all I end up doing is moving my decimal 5 places to the right, because our number system is in powers of 10, right? If I took 3 times 10, I'd get 30. If I took 3 times 100, I'd get 300, and I just keep adding zeros. So in this case, if I'm going to write this in standard notation, I'm going to move my decimal 5 places. So I have 6.693. I would go 1, 2, 3, 4, 5 places over. So I get 669,300, which is 669,300. Now, if you're going to do scientific notation on your calculator, we won't do a whole lot on here, but maybe you take science class or you do a different math class. To put this in your calculator, you would put in parentheses 6.693 times 10 caret 5. Since I'm not doing any operations with it, I really wouldn't have to have the parentheses just on that. But if I was multiplying or dividing or adding, I'd want the parentheses around it.
So you do want the parentheses?
So, if you punch this into your calculator and hit equals.
With the parentheses around it.
Yeah, here it won't matter, but it doesn't hurt. It doesn't hurt to put the parentheses. We're not doing any adding, subtracting, multiplying, or dividing, so we really wouldn't have to have them on that.
Equals 669,300.
There you go. So I get the same number. So my shortcut just is, if I have 10 to the 5th, I'm multiplying by 10, 10, 10, 10, 10, 5 times, moves my decimal 5 places to the right, makes my number bigger. So now, on the next two, they're in standard form. They want you to put that number in scientific notation. So if I'm going to put my number in scientific notation, because I always want my first number to be a number between 1 and 10, I'm going to put my decimal behind the first digit. So I would have 2.860.
Why?
Right? 2.86 is between 1 and 10, right? So it always ends up going behind that first digit. Now I can shorten this up because I really don't need the extra zeros on the end. So I'm going to get rid of the 0 and just use 2.86. Now I'm going to say, okay, what power of 10 do I have to multiply it by to get it back to it where it originally was? Well, if I put it back here behind the 2, I have to go 1, 2, 3 places to the right. So I would say times 10 to the third power. So 2.86 times 10 to the third is the same thing as 2,860.
Okay, now how did you figure out where to put that decimal?
It always goes behind that first digit because it has to be a number between 1 and 10. If I don't move it far enough and I use 28.6, I don't have a number between 1 and 10. If I move it too far and put 0.2, I don't have a number between 1 and 10.
Okay.
So it's always behind that first digit. So on number 6, where should I put my decimal?
7.5.
7.55, right? 7.55. I only get to drop off the extra zeros, but this one didn't have any extra zeros. So I'm going to have 7.55 times 10 to the squared to the second power, because I just have to move it 2 places over to get it back to where it originally was. So you have scientific notation that has positive exponents. You also will have scientific notation that has negative exponents. It means technically really that you're dividing, but you're moving your decimal backwards. When I divide by a power of 10, it makes my number smaller and it moves my decimal backwards. So if I have 4.46 times 10 to the negative 6, means I'm going to move my decimal 6 places backwards. So I'm going to move it once for the 4, and then I've got to go 2, 3, 4, 5 more times, and I'm going to have 5 zeros in front of that 4. Of course, in standard form, we don't leave nothing in front of that decimal, so they're going to stick a 0 there also. So I'm going to have 0.00000446. So, again, if I want to check that out with my calculator, we're going to put in 4.46 times 10 caret negative 6. And since we're just doing the number without any operation, we don't have to put the parentheses, but it certainly doesn't hurt to put the parentheses around it. So, grab your calculator there. Put in 4.46 times 10 caret negative 6. What happens?
5, yep.
I get 0.50446, right?
Mm-hmm.
Now, if your number would happen to have a really big number here and it's too big to fit on your calculator, maybe it was times 10 to the negative 20, your calculator then is going to put it in scientific notation. So just for fun, let's do this. 2.23 times 10 to the negative 20th power.
Negative 20?
Yep. So 2.23 times 10 caret negative 20. So when you hit equals, because it won't fit on your calculator screen, this is how it shows scientific notation. 2.23, a little times 10 to the, and then the negative 20 is up there. Because it wouldn't fit on your calculator screen with all those zeros. So So if you do see something like that show up on your calculator, it's your calculator putting it in scientific notation because the number's too big to fit on your screen. Forgot. I don't get used to this new program yet. So now they are going to have you put some values in scientific notation. So, thinking about where we want that decimal to go. The same rule applies. We want our first number to either be between 1 and 10, or if we have negative numbers, between -1 and -10. Where do you think I should put my decimal on this one?
Between the 9 and the 5?
Exactly. So I'm going to have 9.573 times 10 to the, and if I put my decimal behind the 9 to get it back to where it originally was, what do I have to do?
Times 10 to the -3?
Exactly. I've got to move it backwards 3 places, so I have times 10 to the -3. So number 9, if I'm going to write that in scientific notation, what would I write?
9.439
9
times 10 to the 1, 2, 3, 4, 5,
-5, exactly. So the most common thing I see people when they make a mistake on these ones is they forget on the decimal ones to put the negative exponent. If I have a whole number, that one's going to have a positive number, but if I have a decimal number, that one should have a negative exponent. Alright, the next thing here is, gosh, it keeps moving me way back down, way back up to the top. The degree and leading coefficient of a univariate polynomial. Man, that has a lot of big words. A polynomial just means you have more than one term in your expression. Terms in math are separated by plus and minus signs. So the 2v is a term, the -12 is a term, the 6v to the 9th is a term. Poly means many. I've got many terms. In this case, I've got 3 terms. It's a univariate one because I only have one variable. It's a v. I don't have a v and an x in there. When they're talking about the degree and the leading coefficient, they're talking about if I put my polynomial in the best form. If I put my polynomial in the best form, I start with the highest exponent down. So if I were going to rearrange this polynomial to put it in the best order, I would put this term first because it has the highest exponent. So the 6v to the 9th would go first. Then I would put the 23v, which is a positive 23v, and the constant term, that number, -12, just goes on the end. So that's the best order for my expression.
You don't have to solve it?
You don't have to solve it, no.
Huh.
Now, we still have to answer the questions using our math terms. They want to know what the leading coefficient is. Coefficients are numbers in front of your variable. If it's the leading one, it's the very first one. So in this case, 6 is your leading coefficient. Exactly. The degree of your polynomial is asking what is the exponent of your highest term?
9.
The 9.
Okay, I need to write that down. Coefficient is what now?
The coefficient is the number in front of your variable, so the leading coefficient is the very first number that you have in your expression. The coefficient is your number in front of your variable. And the degree, if we're univariate, is your highest exponent that you have.
Highest exponent?
Yep,
Always the highest exponent.
always the highest one. So they'll talk about a second degree polynomial. That's one of those that has an x squared. I don't know why it wants to keep moving every time I clear the board, but oh well. So number 11. If I were to rearrange that and put it in the best order that it could be in, what order do you think I should put it in?
18?
No.
Because I'm not understanding that. Let's see, what the.
You want the one with the highest exponent first.
Seven
So
Y.
7y.
So the negative
7y.
7y to the 6th would go first.
Negative 18 to a Y2. And then 12.
Minus 12y
And then 6.
plus 6. That would be the best order for my polynomial.
So then the leading coefficient would be negative 7.
Exactly.
And then the degree would be 6.
Yep.
Wait, did I just do that?
You did just do that.
All right.
Okay, tell me what a polynomial order, is that what we're doing there?
That's what we're doing here.
That's the polynomial order.
This whole thing is a polynomial and we're ordering it, putting it in the best order, right? So number 12, if we rearrange the order of that one so that it's in the best order, which term should go first?
V, a negative V,
The negative v to the
third,
third,
and then plus 10V to the second, plus 2V, and plus 10V, or plus 6.
plus
yeah.
6.
So then it would, the leading coefficient would be negative 1, right?
I'm waiting for Christine to get all this written down.
Oh, come on, catch up.
I'm
Just kidding.
trying.
Just kidding.
Rose isn't writing any notes.
I probably should though.
She probably should though, because she's learning from last semester that she sometimes forgets stuff.
Girl, I forget stuff, so I forgot stuff this morning.
So she said we got to start with the negative v to the third since it has the highest exponent. The 10v squared went next. The 2v went next. And the 6, the constant term, the one without an exponent or variable, goes on the end. So then she said, okay, my leading coefficient, they were trying to be tricky, but they didn't fool Rose. This is a negative 1v to the third. So my leading coefficient is negative 1, and my degree is the 3. So if the number isn't written specifically there, we understand that it's a 1, and in this case that it's a negative 1, since there's a negative there.
Couldn't fool Rose.
No, she's right on top of it today.
She's just recording it all.
She is. She's probably recording it and putting it on Facebook to say, see, look how smart I am.
No, Snapchat.
Oh, Snapchat. That disappears too fast. Well, I guess you can screenshot it. Okay, so now we're going to do the degree of a multivariate polynomial. Multivariate just means there's a whole lot of variables. When you find the degree of each term, what you're going to do is add up the exponents. The degree of the polynomial will be the highest one that you get. So what I'm going to do is figure out the degree of each term separately. I have 4 terms in this problem. All the way to the minus sign, 16w to the 4th, v squared, u to the 3rd is one term. Here, the minus 3v to the 7th is a term. The plus 7 is a term, and then the u to the 4th w is also a term. So if I'm going to figure out the degree of each term, I'm adding up my exponents. 4 plus 2 plus 3 would give me 9. This one just has a 7. This one doesn't have any variables, it's going to be none.
And 4.
And not 4,
5.
5. So if I were going to rearrange this one, this term would go first, this one would go second, that one on the end would go third, and my number would go last. They're not asking us to rearrange this one, they just want to know what the degree of it is. The degree is the one with the highest sum. 9 was the degree that we got. So number 14, again, I'm going to separate all of my terms. They're separated by where those plus and minus signs are so that I can find the degree of each term. So if I have 10u to the 4th, w to the 5th, y to the 3rd, what's the degree of that term?
12.
12. If I have a minus 6w, the degree of that term is
1.
1. If I have a plus 4, the degree of that term is
0.
0. And if I have y to the 9th, u to the 6th, I would get 15. The degree of the polynomial is which one of those numbers? The 15, because that's the biggest one. If I were to rearrange it, that one would go first, that one would go second, that one would go third, and that would go on the end, right? So, number 15. We want to give the degree of our polynomial. We're going to find the degree of each of those terms. So the degree of the first term would be 9, the second term 0, the third term 4, and the fifth term.
9.
What's the degree of my polynomial?
Tie.
It's a tie, but it's still 9. Even though they both had the same thing. And when you have something like that, it really doesn't matter which one you put first. They're both 9s. One or the other could go first and it'd still be okay. So, just some crazy math words.
So
Oh my gosh, I guess.
when you do this on Alex, do you have to put like what the number is, or do you just write the 9?
You just put the 9 in on this one. They're just asking what is the degree, so you just put the answer in.